Okay, so we're now going to look at combining inclined planes and ideas of connected particles. That means pulleys, tension, and so on. So let's get into this question. So two particles, 5 and 10, are connected by a light inextensible string. The string goes over a smooth pulley, so the pulley is smooth, which is fixed at the top of a rough inclined plane. So there's friction, and we often have to have a think about how we place friction. Let's start trying to kind of draw this then and get an idea what this looks like. So what's the general situation? Well, the general situation that you're going to have is a block on a slope, the pulley at the top, and then the string is going to go over, and there's going to be something else hanging off of it. Okay? And then what will be the steps that we will do? Well, we know their weights. So on this one, it probably won't surprise you. We'll break this one up. We'll do our normal reaction and so on. We're also going to draw T for tension, and we'll draw it as the same for both of these because the string is inextensible and the pulley is smooth. So the tension will be the same on both sides. Okay, so which way up will it go? Will it go down the slope, this block, or will it go up this slope? That's what we want to scan the text for next. So P rests on the inclined plane, Q hangs off the edge, so this is what we're talking about. Alpha is the angle, tan alpha is 0.75. Okay, so another good thing to do would be one of those triangles where you work out what sine and cos is. So you could do 0.75 over 1, but you might realize that 0.75 is the same as 3/4. So it's one of those 3, 4, 5 triangles again. And while we're here, let's just write what sine and cos is. So that's 3/5 for the sine and 4/5 for the cos. Now I'm going to jump ahead and show you what the diagram is, but I want you just to kind of make sure for yourself that you'd be able to piece that together from the information that's given here, because we always have to be ready for a question where it's not drawn for us. So first thing we're going to want to do is to come up with our force diagram. So notice how for P I've kind of done the same thing that we've been doing the whole time. The 5G, I'm sort of finished now with the 5G. I've broken that up. So I'm doing my parallel perpendicular thing here. So I've got in purple the parallels, I've got in green the perpendiculars. What's going on over here with Q? Well, that's sort of its own separate thing, okay? That's vertical only. So I've just got my T and my 10G. So there's three sort of equations. There's that green one there, there's that purple one, and there's that blue one. And that's more or less all we should need. The thing that's quite hard in this question, though, is knowing which way the friction goes, because there's no clue. It doesn't say that it starts to go up or it starts to go down, because in general, you know, this one could be a really big number, or this one could be a big number. So it's not immediately obvious how to place the friction. So how do we do it? Well, what we've got to realize is that 10G is quite big compared to 5G, isn't it? And when you do 5G sine alpha, well, sine alpha, I think sine alpha was 3/5. Yeah. So 5G sine alpha is actually 3G. So you've got 3G sort of fighting against it. And then you've got 10G pulling the whole system down and over here. So it's safe to say, although definitely not obvious, I would say this was quite a hard one to know how to draw the friction, that mu r should be going that way. Okay, and now we should have enough information to start sort of working things out. So let's handle these equations one at a time. I'm going to do the r equals because that's the easiest one here. So r again is equal to 5G cos alpha, and cos alpha is 4/5. So r is 4G. Okay, so we can just use r as 4G anywhere we like now. How about this purple equation? Well, I'm going to do T And I'm not going to do an equals. I'm not going to do an equals because this whole thing's moving. Find the acceleration. There's acceleration, so it's not an equals scenario. If you think the thing has acceleration, what you want to do is you want to set up an F equals ma. So I'm going to say that the whole system's sort of going up and over. So I'm going to say t minus mu r minus 5g sine alpha is going to be equal to ma. And I know quite a lot of these numbers, so I know it's t minus r is 4g, and this is 0.2. So have I actually written that down anywhere? No, I don't think so. So I'm going to just say, what was that? 0.2 times 4g minus, now 5g sine alpha, we just said that that was 3g earlier, because sine alpha is 3/5. ma, well, it's the mass of the thing that I'm dealing with, which is a 5. So that's just a 5. So 5a. Yeah. And then if I tidy this up just a little bit more, I can get t minus 0.8g minus 3g equals 5a. All right, so what do I do next? Well, the next thing I want to do is I want to deal with this blue one that I've got here. So for the blue one, I'm going to say, that down is the positive direction. So I'm going to say that this is another F equals ma. Okay, so 10g minus t is equal to ma. And what's this? What's the m in this case? It is 10a. So you end up with, let's do that slightly neater, shall we? Or not? There we go. So you end up with two equations, this one, and we're going to sort of add them together. Add them together tends to be the best way to do it because there's a positive t and a negative t. So if you add them together, the t's will be eliminated. So if you do t minus 3.8g equals 5a and 10g, how do I want to write this? In fact, I could even write it like this so you can kind of see what's going on a little bit better. So 10g minus t equals 10a. If you add those together, you will get, what's that? 6.2g equals 15a. Yeah. And then the acceleration you'll get will be 4.1. So you might remember doing something similar in year 12. The idea is that if you do one equation with t minus or minus t, yeah, and then the other way around, if you add them together, you get this pretty neat result. And then what you tend to do once you have this acceleration here is you just sub this into another equation. So, for example, you go back to this one up here, and you say t equals 5a plus 3.8g. You sub in your value, and you can see there that you'll get your value. So you get on this one t equals 57 newtons to two significant figures. So that's how it goes. They're not bad questions. You just got to get your force diagram correct at the start. Thinking about where to put friction, we've always got to be careful with that. But it's pretty similar to the ones that we've been doing before. So let's have a go at one more example with that one there. So one end, I'll just check this is the right question. So 2 and 5, yeah. So we started with a basic diagram to help us, and let's go through the same steps again. So one end of a light inextensible string, block A, 2G. Okay, well, shall we resolve it? We know we're going to have to do it anyway, so we might as well just do it straight away. So that's going to be 2G. That one's going to be 2G. This is opposite, so that's 2G sine theta, which then means the other one is going to be 2G cos. We'll do the R because this one is in contact with the plane. That's why it has an R. This one is not. It's not in contact. It's just in the air. So it does that. We know that this is a string as well. So let's just do this. And in fact, let's do that. So those are going to be some of our key forces. So smooth, oh, it's a smooth plane. Great, so we don't even have to draw friction. Greatest slope, smooth pulley. Yeah, they will give you smooth pulleys, okay, for the normal A-level. I think we've got everything. So the only thing I'm kind of looking out for here is if it's released from rest, because that could mean that they do a SUVAT or something. Right, show that the acceleration is this, find the tension. Okay, so we really do have the same question again here. We might not even need to do the perpendicular. So you don't tend to need to do this perpendicular one if you don't have any friction. That's how it works. So it's going to go up and over, isn't it? If you think about how big 5g is compared to 2g. So for the first one, I'm going to do t minus 2g sine 30 equals ma, which is t minus sine 30 is a half, so that's just t minus g equals 2a. And then the other one, I was using blue before, so let's go back to blue. So for the other one, I'm going to do 5g minus t equals ma, which is 5g minus t equals 5a. Very common, one of them has a g and then the other one has an a. So these two are going to be my equations that I add together. Just double checking my work. 2a t minus g. Yeah, okay, they've done the same thing as me. So that should give you then, if you add equation number 1 and equation number 2 together, you'll get 4g equals 7a. Yeah, so if you do 1 plus 2, and then a equals 4 over 7g, which I think was what was given to us in the question. Find the tension in the string. Well, you just use one of these equations that you want. So you can sub into 1. So if we sub into equation number 1, t equals 2a plus g, if I add the g to the other side, which equals 2 lots of 4 over 7g plus g. Yeah, so t equals, what's my final answer from that? 15 over 7 newtons. Okay, so you see the first part there is really quite nice. State how you have used the fact that it's inextensible. Okay, so because it's inextensible, the tension of the string is the same on either side, and therefore the acceleration is the same. Okay, and final thing is a less obvious one. So calculate the magnitude on the pulley. So you do sometimes get a question like this. So it's not super common, but we need to talk about how to deal with the pulley. So the pulley has got this going on, okay? The red are the forces that are acting on the pulley. And it wants to know, what's being done to the pulley, because you've got this string sort of pulling it to the left and sort of pulling it down. So the pulley, if you want to know sort of what's going on with the pulley, is the pulley is sort of getting pulled in this direction. That's essentially what's going on. Okay. What exactly do they want? The magnitude of the force. Okay. So I'm going to just draw the pulley separately. So if I draw the pulley here, what were the forces? There was a T going on like this, and then there was a T going like this. Any angles? Right. So that angle at the top there is 30. Yeah. So if I do if I draw on something like this, there's a 30 there. So what should we do here? Well, what we should do is we should break up this T that just goes down. That's great. But we should break up this diagonal one into some amount that is horizontal. In fact, if I write the t on the hypotenuse, you might see what to do a little bit better. And some amount of vertical. Can you see that my arrows add together to give the same result there? So what's this side going to be called? Well, this is going to be t cos 30. And then the green one is going to be t sine 30. Yeah? So what's going on vertically here? Well, what's going on vertically is it's t down and t sine 30 down. So it's t plus t sine 30. There is no other force going on here, all right? We're just going to say what, because it does say what the string is doing, right? What's the string doing to the pulley? So this is what the string is doing to the pulley. We don't need to make it any more complicated. It's got tension, and we look at the overall result. So vertically, there's a lot going on. And horizontally, there's not so much going on. So horizontally, it's just going to the left by t cos 30. Okay, so what's the magnitude? Well, the magnitude is going to be the square root of this bit squared plus this bit squared. Where did we get t from? Well, we already know the number. It's 15/7. Okay, so we're just going to do that with, with t equals, what do we say it was? 15/7. And if you do this, okay, if you do this, you should get to 15√3/7 Newtons. All right. They could also ask you what's the direction of it. So, like, there are some other questions that you can have, the direction or the force as a vector, but this is the magnitude. But all of those questions you sort of handle the same way. So you draw them out like this, and you kind of resolve any diagonals. If it said what angle, what I would do is I would take this information here and I would sort of draw this as a triangle. Okay, so I would make one side, let's keep it in one color to make it less confusing. I would make one side, the vertical side, I would make this t plus t sine 30. And then I would make it to the left. Yeah, to the left, I would make it t cos 30. All right, and then I could, I could do some sort of trigonometry or something to find out the angle if they ask that, because they do ask that sometimes. But that's sort of how to handle when you get asked about things on the pulley. You tend to have to do something like this. The bread and butter skill is writing t minus and something minus t and using f equals ma though. Okay, so hopefully you feel ready now to have a go at some of the test your understanding questions.